Factors affecting the strength of the acid. There are several factors which is going to affect the strength of the acid, namely the electronegativity, the size of the atom, hybridization, inductive electron withdrawal, and electron delocalization. Let's see one by one how these are going to affect the pKa of the compound. First one is the electronegativity. Electronegativity is definitely going to affect the pKa values. Let's see how the electronegativity is going to affect the pKa values. When you're comparing the atoms in the same row, then they are going to have this pretty much the same size, right? And the strongest acid is the one which is attached to the most electronegative atom. Let's compare these atoms: carbon, nitrogen, oxygen, and fluorine. All of these atoms are exactly in the same row, which means they are going to have about the same size. Here, the relative acidities are going to be of this order, where you can see that HF is a strong acid and CH4 is a weak acid. Now, why should HF be a strong acid? Because it does have a fluoride ion, which is more electronegative. As the fluoride ion is trying to pull more of these electrons towards itself, the hydrogen can be lost easily. And remember, what is an acid? An acid is something which has the tendency to lose the proton, right? So because of the high electronegativity of red ion, the hydrogen can be lost easily, and therefore this should be a strong acid. And this one should be a weak acid. Because carbon, the electronegativity difference between carbon and hydrogen are approximately the same, right? And therefore the hydrogen cannot be lost easily. Now, what about the strength of the bases? We have come across this important concept that stronger the acid, weaker it's going to be conjugate base. Now, if HF is a stronger acid, then its conjugate base should be a weaker base. So therefore, F minus is a weaker base. And in the same way, if CH4 is a weak acid, then its conjugate base should be a strong base. Now let's see, why are alcohols stronger acids than amines? We have methyl alcohol here, which has a pKa value of 15.5, and we also have methylamine, which has a pKa value of 40, which means this is going to behave as a weak acid, whereas this one is comparatively a strong acid. Now, what is the reason behind it? Why is this alcohol going to behave as a strong acid compared to an amine? The reason is the atom where the hydrogen is attached to. Here, the hydrogen is attached to an oxygen, which is more electronegative, right? So oxygen is more electronegative compared to that of nitrogen. So which means it's going to pull most of the electrons towards itself, leaving the hydrogen free, right? Therefore, since methyl alcohol has the ability to remove this hydrogen very easily, it's going to behave as a stronger acid compared to methylamine. And why are protonated alcohols stronger acids than protonated amines? And it is exactly for the same reason. Here, the main difference is the atoms where the hydrogen is attached to. In protonated methyl alcohol, you have the hydrogen attached to oxygen, which is more electronegative than nitrogen, right? And therefore, this has a pKa value of minus 2.5, which means this is going to behave as a strong acid compared to a protonated methylamine, which is going to behave as a weak acid. The third factor that is going to affect the pKa value is hybridization. Hybridization is going to affect the electronegativity, which in turn is going to affect the pKa value of the compound. Let's do this with an example. Here are three different compounds. We have ethyne, which is acetylene, ethylene molecule, and ethane. When you compare the pKa values of these compounds, you can see that acetylene molecule has a pKa value of 25, which means this is going to behave as comparatively strong acid, while the ethane molecule is going to behave as a weak acid. Now, what is the reason why ethyne molecule should behave as a strong acid and ethane should behave as a weak acid? Now, the basic difference between these molecules is the presence of the different kinds of bonds, right? We have triple bond here, double bond here, and single bonds here. And accordingly, the hybridization of the carbons is going to be different, right? This carbon right here is sp hybridized, and this one is sp2 hybridized, and this one is sp3 hybridized. In general, an sp hybridized carbon is more electronegative because it has got more s character, compared to the sp2 hybridized carbons and sp3 hybridized carbon. And because this carbon right here is more electronegative, this hydrogen can be the hydrogen that is bonded to the carbon can be lost easily, and therefore this is going to behave as a more strong acid compared to ethene and ethane. The size of the atom to which the hydrogen is attached is also going to affect the pKa value. Now, when you compare the atoms that are different in size, the size of the atom is going to become more important than its electronegativity in determining how well it's going to bear its negative charge. Let's do this with an example. Here is the relative acidities of the different acids, and you can see from here that the Hi is a strong acid and HF is a weak acid. Now, why should Hi be a strong acid? Let's consider the conjugate base. If Hi is a strong acid, then the corresponding base or the conjugate base is going to be a weaker base, or it is a stable base. So this one should be a weak base and this one should be a strong base. Now, why is I minus a weak base? The atom iodine is larger in size, because of which this negative charge can be distributed on the larger volume of this iodine atom and therefore can behave as a weak base. But in the case of fluorine, since it is a smaller atom, this negative charge have to occupy a very small volume of space and therefore it should behave as a strong base. Here are the pKa values of some of the compounds. When you're going to compare the atoms in the same row, then you needed to take electronegativity into consideration, where the strongest acid is something where the hydrogen is attached to an atom that is most electronegative. So here in this case, HF is a strong acid, whereas CH4 is a weak acid. But when you compare the atoms in the column, then the strongest acid is something which is going to have the largest anion attached to the hydrogen. Say, for example, between Hi and HF, Hi is going to be the strongest acid because the I minus is well stabilized, where the electrons are going to be spread over a large volume of space. Apart from the electronegativity, size, and hybridization of the atom, the substituents which are present in the compound is also going to affect the pKa value of the compound. Now let's do this with an example. Here are 4 different compounds. This first one is acetic acid, and the rest of the compounds are substituted acetic acids. Acetic acid has a pKa value of 4.76, whereas the rest of the molecules have pKa value around 2.8. So taking this into consideration, we can definitely say that acetic acid is a weaker acid, while the rest of the acids are comparatively strong. Now, what is the reason why these acids should be strong? The reason here is inductive electron withdrawal, which is the pulling of the electrons above the sigma bond, through the sigma bond. Let's say that we remove a hydrogen from here, and this is going to lead to this conjugate base. Remember, when you have a strong acid, and that it is always going to lead to the weak conjugate base. If this is going to be a stronger acid compared to that of acetic acid, then this conjugate base should be a weak base or a stable base. Now, what is making this base a weak base? Now, because of the electronegativity of bromine, these electrons which were once concentrated on oxygen is now going to go travel through the sigma bond and reach this electronegative atom. And therefore, this conjugate base is going to be stabilized because there is decrease in the negative charge. So on the whole, when you have electronegative substituent attached to the compound, then it is going to behave as a stronger acid because of the inductive electron withdrawal effect. Also, it is important to note down that the fluorine is more electronegative, and therefore the inductive electron withdrawal ability of fluorine is more compared to that of bromine. And that is the reason why the fluorosubstituted acid is a stronger acid relative to bromo-substituted acid. The substituent effect on pKa is also going to depend on the distance, like where it is present in the molecule. Now let's compare these 4 different compounds, and all of these have exactly the same number of carbons, right? But the position of the bromine is different in these compounds. So here the bromine is closer to the carboxylic acid group, and therefore the inductive electron withdrawal of bromine is going to be more here, and therefore this is going to behave as a very strong acid compared to this one where the bromine is on the far end of this molecule. Why is a carboxylic acid a stronger acid than an alcohol? Here is the structure of an alcohol and a carboxylic acid. And you can see from here, the carboxylic acid is a very strong acid compared to that of alcohol because of its lower pKa. Now, what is the reason why the carboxylic acid should behave as a stronger acid compared to alcohol? Now, there are two important things that comes in play here. The very first one is the inductive electron withdrawal. In carboxylic acid, you have an electronegative atom that is attached to the carbon, which has this oxygen, right? Once you remove this hydrogen, then these electrons are not going to be simply existing on this oxygen. Instead, because of the inductive electron withdrawal, this oxygen is going to pull the electrons through inductive electron withdrawal. Whereas in the case of alcohol, there is not going to be any inductive electron withdrawal because there is no electronegative atom present. Now, the second thing here is the delocalization or through resonance. When the carboxylic acid loses that hydrogen, the electrons are not going to be simply concentrated on one oxygen. Instead, it is going to be distributed between the two oxygen, leading to another resonance contributor. But here in the case of alcohol, after it loses the hydrogen, when it forms the ethoxide ion, the electrons are going to be localized, which means there is no way that these electrons can shift, right? And because of which this is going to be a stronger base, right? Whereas this is going to be a stable base. And if the conjugate base is stable, then the acid that it had started should be a stronger acid. And that is the reason why carboxylic acid is a stronger acid than alcohol. Summary of factors that affects the acid strength. When you're going to compare the atoms along the same row, then we have to consider electronegativity. Greater the electronegativity of the atom that it is attached to hydrogen, stronger would be the acid. Here, HF is a strong acid compared to methane because fluorine is more electronegative, which means it is going to pull most of these electrons towards itself, leaving behind the hydrogen. When you're going to compare the atoms along the column, then it is going to be the size which is going to decide the strength of the acid. A stronger acid is something which is going to have a larger atom attached to hydrogen. So here, HI is a stronger acid because once the hydrogen is removed, the I minus is going to be stable because of its larger size, where the electrons can occupy a huge volume of space. The hybridization of an atom is going to affect the electronegativity of the atom. An sp hybridized carbon is more electronegative, and therefore any hydrogen that is connected to sp carbon is said to be acidic, and therefore acetylene molecule is a strong acid compared to ethane. Inductive electron withdrawal affects the strength of the acid by pulling the electrons through the sigma bond. Okay, when this hydrogen has been lost, these electrons are going to go on to the most electronegative fluorine atom, thereby stabilizing the conjugate base. And if the conjugate base is stabilized, then the acid that it had started from should be a strong acid. And also the position of the electronegative group is also going to affect the strength of the acid. Where if it's going to be closer to the hydrogen that needs to be lost, then it's going to be a strong acid. The electron delocalization will also affect the strength of the acid by stabilizing the conjugate base.